Good morning, seventh grade. This morning, Mrs. Dishon is going to take you through a couple activities today with a video. This is going to be for lesson 4 called Deep Dive. Activity 1 is going to be your homework. So what I'd like you to do is you're going to watch this video with me on activity 2, and then you're going to come back here to activity 1 on page 405 and complete this problem. So I'm going to take you to activity 2. Activity 2 is a little bit harder. It's 2 steps, so that if I can give you all the steps and the process you need, you guys can do this activity 1 on your own. So we are making inequalities with equations, and I want you to notice that our problem right here is about a submarine that can dive to a depth of 3,300 feet. This is going to be below sea level, which means I'm looking at a negative number when it says gives me the word below sea level. And then it says it can ascend. Ascend means positive because that means we're going to come back to the surface. And they're going to do this at a rate of 650 feet per minute. So every minute that goes by, we're going to have a rise of feet. Our depth is going to increase 650 feet. So the first thing I want you to notice is that our homework asks for an independent and a dependent quantity or variable. So independent is the one that's going to pass, that doesn't need us to do anything, and that will always be time. Now we can call that M for minutes, we can call it T for time, and we'll talk about that as we get to our graph. As we move down though, our dependent, what depends on the time, how long we're in the water, how long we're rising, that's going to be our depth. And that will be feet per minute, something going up. So then it wants us to go ahead and write an equation. Well, our equation, I want to know when we start this problem, when we're going to start beginning, our depth or our distance below the surface, we started out at negative 3,300 feet below sea level, but we're going to add 650 feet every minute. So I'm going to put M. So if I go down for 1 minute, or I'm rising, for 1 minute, I'm already 3,300 feet below sea level. I would increase by 650 feet every minute we're under the water as we're coming up. Now, the two things we need to know is your independent variable is always your X. So your independent variable is time, and we're going to measure that in minutes, and I'm going to use M in my equation. And then our dependent variable is going to be our depth, and that is going to be in feet. And here's where your equation comes in. So this is just like when you were working on Mathia. You're starting at negative 3,300, but we're going to increase 650 feet every minute that passes. So if I get into the water and I have no minutes that pass, this is gone. My depth, or my answer, is going to be negative 3,300. But if I go into the water and I'm going to increase my depth, I'm going to be in there for 1 minute, ascending back to sea level. I'm going up 1 minute, means I'm rising 650 feet. So if I take 650 positives with this 3,300 negatives, I'm going to use this equation. I would put a 1 in for the M, and it would end up being negative 2,650. I would like you to pause the video, and I would like you to complete the problem. Okay, now that you worked on that, after you filled in the rest of the table, you're going to have a question that says, why does the table end at 5 minutes? Well, to check your work at 5 minutes, you should end up with a negative 50. And it says, why does it rise? Because in the next minute, you would be at the surface. Because surface is going to be 0 feet. That's where you crest and you hit the water. So when feet, our depth, becomes 0, that's where we're at the surface. So as we look at these problems and it talks about what do you know about these numbers? What do you think all the values are? Well, if I'm time, it says it wants me to write an inequality. So time can be a lot of things. On my graph next door, or my table, time was anywhere between 0 and 5 minutes, but time can't be negative. So time has to be greater than 0 because I don't want to be in 0 mode and then just stay there. It can be equal to 0. So I can include greater than or equal to 0, but time is going to look something like this. But because this problem is going from negative up to positive, time can also, it has to stop when we reach the surface. So you guys found out that we reached the surface at 5 minutes. So that means our time has to be less than or equal to 5. So when we started, time was 0, we were good to go. And then when we reached the surface, time was 5, we were almost there. So this problem could be less than 5 minutes before you're going to reach the surface. If we're talking about depth, our depth has to be less than or equal to 0 because we're going underwater. We have a negative number. And then depth has to be greater than or equal to negative 3,300 because we're going to go down. We can go a lot of places. So our problem right here is we're going to be between 3,300 underground, underwater, and then the surface. And then what do you notice about the depth in relation to each table after 1 minute before and 1 minute after? So I want to notice that after each one, our answer is going to increase 650 feet because we are rising 650 feet every minute that passes. So when it says what's the unit rate, when I want to write a unit rate that is something over 1, so we're talking about 650 feet over 1 minute. So remember, a rate is always written as a fraction. So if I go back and use my equation again, I want you to answer these 3 questions. This says 2.5, so minute would be 2.5. I'm going to take my negative 3,300 plus 650. I'm going to plug in my 2.5 in the minute mark. Now, when it says 90 seconds, you're going to notice 90 seconds is more than a minute. It's a minute and a half. And 45 seconds is less than a minute. So 45 seconds is 3/4 of a minute, or 0.75. So when you do these 2 problems, you have different numbers to plug in for the minute. I would like you to pause and solve these 2 problems. Excellent. Now for number 8, we're going to switch it. So number 8, they're going to give us our depths below sea level. And so what that means is I now know the D, or the depth part of our equation. So 1,000 feet below sea level is going to be, we got to find out how much time it took us to get there. And this is going to be our equation. We're going to fill in the depth part and solve for how many minutes. You're going to do the same thing for this one. You're going to be at a negative, I'm sorry, this is a negative, you're underwater. So this one's going to be a negative 2,100 is equal to negative 3,300 plus 650 times m, whatever m is going to be. You're solving for m. The last one, sea level. It's hard to show you in my book. It doesn't want to reach, but sea level is going to be 0. So I want to know what is the time when we actually touch sea level. So I don't want a number here other than 0. Sea level would be at the top. I want you to try these 3, pause the video and try these 3 problems. Now we're going to continue on page 410 with our graph. It says, I want you to draw a box or an oval on the graph to estimate each one. I want you to draw a box or an oval for the time the submarine is above 1,000 feet. So right here is 1,050. So we're going to use our graph to do a section right here. So I want to know when you're more than or above 1,000 feet below sea level. So I'm going to take this, and it says estimate. There is the section I'm going to be above 1,000. Now, what this means is I'm looking at a time. So if this is a 1,050 mark, which is here. If I go up, that's about 3.5 minutes. So if I use my graph, I'm going to do my estimate, and then I'm going to look at my graph to give me an estimate amount of time. Now I want to put a box or an oval, and because I already use an oval, I'm going to use a box. This is below 2,000. So here's 2,100 touching my graph. So I'm going to give a box that lives in this region. And because I'm going to be in this region and I'm going to look at my timing, this right here dot is kind of my estimate. That means I'm going to be at about 2 minutes. So 2 minutes from our rising point, I'm going to be anywhere between negative 3,300 and 2,000. And then if I keep going at 3.5 minutes until I reach the surface, this is the section I'm going to be at 1,000 feet below sea level or above. Now here it says write an inequality to determine the submarine above. So now we're talking about letter A still. I'm looking for my oval. I want negative 3,300 plus 650 rising feet per minute is going to be greater than negative 1,000. To get to my oval piece, I want you to be greater than 1,000. So I want my depth up here. I want my answer to be greater than 1,000. If I do the same thing, you're going to solve this. I want to know how many minutes that you're going to need to be greater than 1,000. So my estimate up here was 3.5 minutes. So now you're going to actually do the work and see if that's what you get. So then the last one on here is going to be what happens if I'm below this 2,000 mark. Again, we're going to use our equation and we are going to put in, I now want less than, I want my depth to be less than 2,000 feet. And that's negative because we're still underwater. So if I want my equation right here, I want to now support and give me an answer. I'm going to solve that. I'm hoping it's going to be around 2 minutes because according to my estimate down here, I want to know the time that I'm going to be less than 2,000 feet. Now, ladies and gents, please use your notes in this video to turn back to page 405, which is rate activity 1. And I'm going to give you a hint. This is a one-step problem. You are not going to have a depth of 3,300 like we started, but you're going to do the same thing. Give me an independent and a dependent variable with an equation. Use your equation to make all of your chart and graph, and you're going to work as a table to answer the questions about your graph, making box or circles, and then make the equations for that. Enjoy.